Good evening, everybody. My name is Vernon. I am the Public Information Officer and the Assistant Coordinator for the Jefferson County Emergency Management Agency. Thank you all for coming out tonight for our weather spotter training. I have a few things to announce before we start. We'd like to thank our sponsors. We are the Jefferson County Emergency Management Agency is co-sponsoring this tonight along with the Amateur Radio Club of Mount Vernon and the Mount Vernon City Emergency Management Agency, as well as the Mount Vernon Airport. We thank them for providing the location for us to have this event. Has everybody got a weather radio ticket? If you have not, see it at the desk. We have 4 weather radios we're going to give away at the break tonight. One of them is donated by the Jefferson County Emergency Management Agency. We have 2 portable weather radios that were donated to us by Midland Weather Radio. We have another WR100 desktop that was donated by Storm. They are a severe weather reporting group in southern Illinois that works with the counties that Paducah covers. Some final housekeeping: make sure your cell phones are on silent. Our emergency exits are, of course, out those doors and to the back. And out our doors towards the tarmac. Restrooms are at the rear. And just a reminder that there are some weather brochures and SkyWarn brochures at the back. And at this time, I will introduce our instructor, Mike York. He is a forecaster with the National Weather Service in Paducah.
SkyWarn registration form to be wiped. They'll probably provide you with the head count, but in addition to that, if you want to be contacted by us when there's a storm, you can fill this form out and let us know. A lot of this information is optional. You don't have to fill it out if you don't want to, but it helps us out more if you do. And anyway, if you fill this out, it's on the back table, and if you don't have a pen, there's a couple of pens back there too. If you don't want to do that during the break, or if you just don't have time tonight, you can also do it online. This piece of paper is also up there on the back table. This tells you how you can register online. You just go to that website and there's a form. Anyway, my name is Mike York. I'm the National Weather Forecaster at the National Weather Service in Paducah, and I've been there for about 20 years as a forecaster. So I know this area pretty well. I've been up here several times to do damage surveys, and I've done spotter training here. It's been a while, but I don't know how many years it's been. Before I get started on the spotter training, I usually like to talk about the weather. Imagine that. We've had a very active weather pattern so far. The past month or so has been very active. The winter started off very, I guess you'd say, boring from a meteorologist's point of view. We were actually in a moderate drought early in the winter, and really there was nothing noteworthy as far as weather goes. And then all heck broke loose in mid-February. At Paducah, we had 11 inches of snow on February 16th, which was our 3rd biggest snowstorm on record. And then we had 12 inches of snow on March 4th, then that became our 3rd biggest snowstorm, and the one on February 16th became our 4th biggest snowstorm. Mount Vernon escaped the worst of those storms and had much less snow. I'm sure you're not too upset about that. And then we had a couple big rainstorms. We had 2.5 inches of rain last week. Anyway, all of this precipitation has, at least for Paducah anyway, is making it our 8th wettest March on record so far. And we only need 3/100 of an inch more to make it the 7th west. So March is going to go down in the record books as a very busy month for us. There's going to be more rain later this week, but it won't be very heavy, but it'll still put us at least 7th in the record books. So with all the precipitation, the rivers have come up a lot. Here's a hydrograph of the Big Muddy River, and it is in flood stage. This is at the Plumfield gauge, which is in Franklin County. And of course, it comes out of the Rent Lake Dam, and it's starting to go down, but it will still be above flood stage through the day, through the night tonight, and then fall below flood stage tomorrow. It's minor flooding. The orange area is minor flooding, so there isn't really a whole lot being affected except maybe some roads, some farm fields. It is a busy time of year. And we've had some wild temperature swings as well. Our low on March 6th was 6 below 0 at Paducah, and that was the coldest temperature we've had in the month of March. It's never been that cold in March. And then 6 days later, it got up to 70 degrees. So it's been a really roller coaster, crazy kind of weather. It gets the weather juices flowing. Okay, I'll get into the actual spotter class. How many people have taken this class before? That's usually about typical, about half. And if you've already been through it, you pretty much know that there's a lot in it and that you won't be able to remember everything. The whole thing runs about 2 hours, including a 10-minute break. And there's some real technical stuff, and then there's some other stuff that's hopefully fun to learn. Some of it's more interesting than others. But anyway, the whole goal of it is to prepare you to be able to spot severe storms and tornadoes, and then make those reports to us at the Weather Service. All right, storm spotting. Well, a couple things you should know about it. It's difficult to do accurately on a consistent basis. Every thunderstorm situation is different. Every storm season brings new learning experiences. So you're never going to encounter the same thing twice in weather. You probably already guessed that. That's definitely the case. This course in itself isn't really going to make you a trained professional at anything, but it's a good start. And by taking this class, it kind of lends credibility to your reports. So if you make a report to us and identify yourself as a spotter, it'll definitely lend credibility, and we take spotter reports more seriously than we would reports from the general public. Again, you want to absorb everything in this one class. There's a lot to learn. And if you have any questions, just ask. Don't be afraid to chime in or raise your hand or just shout out. There's a lot of stuff that just ask questions. All right, the online spotter sign-up form that I mentioned earlier, that's essentially what it looks like. It prompts you for your name and address, email address, cell phone, other phone. You don't have to fill it all out. In fact, you don't have to fill it out at all, but the more information you give us, the more it helps. It also helps us keep track of how many spotters we've trained, which is important for our records. Okay, the National Weather Service, if you're not familiar, is a federal government agency that is part of the Department of Commerce. And the bureaucracy is up there. It's DOC, then NOAA, then NWS. And everyone in the country is covered by one office or another. There's roughly 110 offices around the country. The Paducah office covers parts of 4 states. We have 58 counties that we cover that are shown there, all the way from around Evansville, Indiana, down to about Poplar Bluff, Missouri, and also from around Mount Vernon down to about the Tennessee border. So we have a lot of territory that we cover, and that's why we have a pretty good staff of about, when I say pretty good, I mean pretty large staff of about, we have 12 forecasters, and we have 4 or 5 interns, and then we have an administrative management category.
Report what you saw or what's happening right now, but avoid trying to predict what's going to be happening minutes from now. Storm spotters are an important part of the integrated warning team. This is the team made up of the National Weather Service, emergency management and public safety officials, and the media, who are responsible for getting critical information out to help people protect themselves from dangerous weather. Real-time weather observations from storm spotters help make this system work by giving emergency managers and local officials information to help them make local warning decisions, by providing the media with ground truth about what's actually occurring, and by giving the National Weather Service details about the local weather that can help forecasters make critical warning decisions.
We have a 1-800 hotline that you can call. This is a spotter hotline. In other words, this is for you to report your weather. 1-800-533-7189 is the number. And if you, go ahead again. Yeah, out of the options that are up there, the most direct, fastest, and reliable way is the 800 line. So that's the one I would use for really major reports, like tornadic activity or things like that. The online report form, which I'll show you in a minute or two, is not as quick, but it's very reliable. When you use that online report form, it alarms at every workstation in the office so that nobody misses it who's at a workstation. And those people who aren't involved in the warning can just dismiss it and ignore it. But the people who need to know will get it, and they will, whereas with a phone call, the person who takes the call will have to shout over everybody. When you make your report online, nobody has to shout. They all see it on their workstation. So the online report form has its benefits, and one of those two I would recommend. Twitter and Facebook are not monitored continuously, so don't use those for, super urgent reports, but you can use those for pretty much any like winter weather reports or fog or any flooding and stuff like that. And then amateur radio is probably your last option, because even though we have an amateur radio desk, it's not normally staffed. If you are monitoring a repeater and you do hear our office on the radio, you can make your report that way, but most of the time it's pretty difficult. So again, please call us on that 1-800 number if you have an urgent severe weather report. If you can't remember that number, you don't have a pen to jot it down, on the back table there are index cards that have our number, kind of like a business card, except it's not a business card, it's got some rules, some severe weather spotting rules on it. It's also got an 800 number. So pick that up if you want. And then when you do make your call, try to be concise in terms and be accurate. Conciseness and specific is the way to go, because if we have a lot of severe weather going on, it's kind of like organized chaos at the office, and we don't have a lot of time to make small talk or, but if you just say that you're a spotter, just like it says here, you're a spotter, you don't necessarily have to give your ID number, which I'll give you at the end of the class. Say what you saw and try to be specific, like if you saw large hail, try to be more specific than that, because large hail means different things to different people. That could be, golf ball size to one person and dime size to another. So try to say quarter-size hail or something like that, and then where it occurred. And when you say where you are, please try not to be too specific, because we've got 58 counties, and it's tough to know every single nook and cranny of every county. So if you can use a well-known city, such as Fairfield or Mount Vernon, and then say how many miles you are from that city in which direction, that's good enough. That'll tell us right away what we need to know. If you're seeing a wall cloud, a funnel cloud, or a tornado, try and tell us where that feature is relative to where you're located. Because if all you say is where you're at, and you see it, you may be off by 5 miles, because the tornado is probably at least 4 miles, or if not more, away from you. So, and that makes a big difference. Every mile is important. And then say what time it was, because even if it was just a few minutes ago, it won't match up with the radar most of the time. If you say you're seeing it now and it really was 3 minutes ago, Well, if the storm's moving at 50 miles an hour, that means the actual location, according to radar, is going to be different than what you're saying. So here's an example of a good way to make your report. Just say you're a weather spotter, and at such and such time I spotted such and such about 3 miles southwest of Fairfield, and then you can use some route numbers if you want, although we may not be able to look those up on an atlas, and then the county that you're in. All right, the online report form is on our website, and if you don't know about our website, it's weather.gov/Paducah, or you can use our three-letter airport identifier for Paducah is PAH, and that's why it's PAH. So either one will work. On the left-hand menu, there's a huge list of menu options, and there's a Submit Storm Report option way up near the top under the current hazards, and that's the one you want. You click on that, and you'll get this form, and it prompts you for what we need to know, which is the time of the event, the date, the county of the event, the location, and again, if you can use the distance and direction from a city or a town, that is optimum. And then the event type, which can be any type of hazardous weather. Dense fog is hazardous, any kind of flooding, hail, and it will prompt you to be more specific about which type. For example, how low was the visibility in the dense fog, or how bad was the flooding, how big was the hail, so on and so forth. Because we need specifics. We always deal with we want to deal with measurements, but a lot of times people have to estimate because they can't measure everything. And then in the additional details area, you can pass along things like your confidence level, like I'm pretty sure it's a tornado, or I can't tell if it's a tornado because the funnel is behind the trees, something like that, whatever you want to put in there. And then the contact information at the bottom, that's purely voluntary. That's more for in case we have any questions about what you saw, whether or not we can call you back. If you do mention that you're a spotter, that adds credibility to your report and gives us confidence that your report is accurate. Because this form is open to everybody, the general public can fill this form out. Now, if you're a Twitter user, you can use the hashtag PAHSpotter, which is for trained spotters. Hashtag NWSPAH, that's for everybody, the general public, whether you're trained or untrained. And then hashtag Tri-State Weather is more for the Evansville media market, meaning anywhere from Carmine and Harrisburg eastward. So probably, in this one, you'd probably want to use PAHSpotter. The platform that we use to monitor Facebook and Twitter is called Hootsuite, and this is an example of the screen that we're looking at with all the Twitter and Facebook posts. We usually send out a Facebook post about twice a day, even in quiet weather. If the weather's really severe, sometimes we send out Facebook posts every minute. Like the day of the Brookport tornado a couple of years ago, we were constantly passing information along on Facebook. Our Facebook page looks like that. We normally, like I say, update it about twice a day with the forecast, basically. Amateur radio, we do have an amateur radio presence. I wouldn't recommend making that your primary way of reporting unless we know for a fact that we're monitoring a repeater. But those are some of the repeaters that we monitor, and we do have Echolink, the Paducah machine. For you ham radio operators here, we do have Echolink on that, and that's the one we monitor primarily. Probably because it's right next to us and we get it real well. If we have a very high-end severe weather event, usually there'll be something on that repeater. So what do you report? Report pretty much anything that's hazardous as a rule of thumb. Any kind of tornadic activity or rotation, meaning funnel clouds, tornadoes, wall clouds, which I'll describe in just a discussed in great detail. Any size hail, flash flooding of any kind of strong winds, even if they're not damaging 40 miles per hour or better, any kind of heavy rainfall amounts, meaning more than an inch or two in a day, and then any kind of damage, injuries, or fatalities, even something as small as trees down is very critical to us. And then winter weather reports, any type of frozen or freezing precipitation, as well as how much is fallen, and then the road conditions associated. And then finally, dense fog is also a hazardous phenomenon. Yeah, the noise, most people use coins. 1 inch hail is the threshold for severe thunderstorms. So if you have quarter-size hail, you have 1 inch hail, and that's our criteria, not our offices, but that's the national criteria for severe thunderstorms. Anything smaller than that is non-severe. Anything from quarter-size up is still severe thunderstorm. A good way to estimate hail, the best way is with a ruler, if possible. But if you don't have a ruler, loose change is good. If it's bigger than a quarter, then most people use either golf ball or baseball, like athletic balls. Walnuts, we had cherry tomato size, which isn't good because cherry tomatoes vary in size. A back table that has what's called the Beaufort scale, and it's really good for estimating speeds below about 50 miles per hour. Above that scale, it's not real accurate because that scale was made in like the 1800s. It's still good for light winds and speeds up to about 40 or 50. But beyond that, it's kind of underestimating or underestimating speeds. Any kind of structural damage or tree damage, you pretty much assume it's over 50. If you have branches down or considerable amounts of tree damage, it's definitely over 60. But anyway, if you don't have anything else to use, if you don't have trees, then usually this is kind of the last resort for estimating those speeds. You already know the speed limits on roads around you. You know when a car is speeding or not, and you can probably estimate the speed of the car. So watch the rain sheets. The rain sheets of the car, how fast will the car be moving. Know the trees and signs in your area. You probably already know how the trees and signs move on a windy day. You can estimate the wind speed on those days. Then watch the trees and signs during the storm and estimate the wind speed from there. But again, tree damage is probably the best way to estimate high winds. A lot depends on the diameter, the type of tree, and whether it was dead or alive. If a rotted tree falls, that makes a big difference. A rotted tree can come down in relatively low winds. If you have a bunch of healthy trees down or healthy limbs, you definitely had some 60, at least 60, maybe 70, 80 winds. So anytime you have tree damage, we really appreciate those reports, even though they may not impress you a whole lot, but we use tree damage reports extensively when we're trying to verify our warnings. Okay, this is a video that shows a 45 mile per hour wind at our office. use this form to help us determine what the wind speeds were. This is part of the Fujita scale, which you've probably heard of. It's the way that tornado intensity is rated. But questions you could ask yourself when you're estimating wind speeds are whether or not the trees had leaves on them or not, whether the tree was healthy or rotted, because both of those things make a big difference. But in general, softwood trees come down at a lower wind speed, or they snap at a slightly lower wind speed than hardwood trees. And hardwoods include oaks, maples, and softwoods are like pine trees. You can send in any kind of photos to that email address, and the information will get to us. The photo on that slide is the Opdyke tornado, which was about 3 years ago, almost to the day. The number of tornadoes in our 58 county area by time of day in the period from 1996 to 2014. And as you might expect, if you know much about weather, tornadoes are usually most frequent in the late afternoon and evening hours. The reason for that, of course, is that that's the warmest time of day when the atmosphere is the most unstable, and thunderstorms need instability in order to develop. However, some of the late night tornadoes after midnight, even though that's not the peak time of occurrence, we've had some very violent tornadoes during that time of day. As far as by month, again, this is for the 58 counties that we cover in the period from 1995 to last year. And tornado season, as you already know, is April and May, and this bears that out. But we also have kind of a secondary peak in the fall. October and November, oftentimes we have some tornado outbreaks then as well. Midsummer is usually very quiet. July and August actually are some of our quietest months for tornadoes. And the wintertime is normally pretty quiet, but we've had some, especially December, but we've had some pretty bad outbreaks in January. Single cells are not severe. On the other extreme, we have supercells. Supercells are very rare, but they are the ones that get all the dramatic headlines because they're the storms that produce tornadoes. They're the storms that produce the intense, very large hail and, the baseball-sized hail. And they get all the attention. And that's primarily the focus of our talk tonight is on supercells, because they are primarily the main producer of tornadoes. Now, you can get tornadoes from multi-cells, but they're typically weaker, short-lived, and much harder to spot, so there's not much you can do about spotting multi-cell tornadoes. So supercell tornadoes are what we talk about here. You've all heard the term wind shear, and don't be intimidated by that. All it is a change in speed and direction with height. As we go up in the atmosphere, if the wind is increasing and changing direction, you have wind shear. That's all it is. That's a necessary ingredient for severe thunderstorms. You have to have strong winds along for organized severe thunderstorms. You can have a pulse severe thunderstorm without wind shear, but to have an organized severe weather event, you need wind shear. And in this example, you have a surface wind from the southeast of 20 miles an hour, and at 10,000 feet, you have the southwest wind is 60. So the wind is turning, it's increasing, and that's what we need to organize these thunderstorm updrafts so the thunderstorm sustains itself, it doesn't collapse in on itself. And if you kind of don't worry too much about this slide because it's not really practical most of the time to estimate shear by looking at a cloud. But you can do it. This picture here on the left, these pictures, they show the cumulus cloud or the cumulonimbus cloud. It's straight up and down. There's no tilt to it, and that's because the wind shear is weak. It's not tilting the updraft. In the picture on the right, there's a lot of tilt to that updraft. The thunderstorm is tilted. It's in a stronger wind shear environment. So the updraft is not collapsing in on itself. It's able to sustain itself as a thunderstorm. The squall line is exactly what it sounds like. It's a line of thunderstorms. And the main hazard with squall lines is usually wind. They can produce tornadoes, can produce hail, but the strong winds are the primary hazard, especially if they're moving rapidly. A lot of times, shelf cloud will accompany the leading edge of the stronger winds. The picture on the bottom right is the shelf cloud. Essentially, it looks like an arc or a shelf. That's because that's the leading edge of cool air undercutting the warmer air out ahead of it. The cool air is more dense, so it undercuts it, and that's why it appears to be a shelf. And as soon as the shelf cloud passes overhead, that's when you get your cooler air, you get the winds pick up and they change direction. If you watch radar much, you might already know this, but if you see a squall line kind of bow outward, like in those circles, the circled areas there, that is usually an indicator of a rapid outrush of air, like an acceleration of the thunderstorm line segment. And so we focus on those bowing segments for strong winds. Anytime we see thunderstorm lines bow outward like that, it's a tip-off that there might be some strong winds. So oftentimes, all our trained spotters were in that area of the bowing line and see if they're getting any strong winds. Again, bow echoes are usually associated with an axis of enhanced winds. Oftentimes severe, but not always. We've had bow echoes that were not severe, especially late at night. If you're spotting the squall lines, it does make a difference what time of year it is. In the spring or summertime, the lines usually move a little bit slower. We usually get the strongest winds on the leading edge of the line. So if you're mobile, in other words, if you're a storm chaser, stay out ahead of the line, look for damage behind the line if you end up getting behind it. If you're at home, estimate the wind speeds by looking at the trees. If you have an anemometer, whether it's handheld or other, that's the best way. We love measured wind speeds. Report any damage that you have, including tree damage or any hail. Now, in the cool season, which we're talking fall and winter here, or early spring, these are dangerous because they usually move faster, say 60, 70, 80 miles an hour, and that makes it difficult to outrun them if you're a storm chaser. So that's not a good method. Tornadoes are hard to see with squall lines. Again, they're usually not the type of tornadoes you have with a supercell. And the chances of seeing a tornado in a squall line are kind of low because unlike a supercell tornado, they're usually kind of in with the rain. They're hard to see. And a lot of times they're at night, and it's just more difficult.
Winning ticket for it is 378011. Okay? I would like to ask after the training that all of our winners group up against one of the walls, the storm group wants to get a picture. We also want to send a picture to Midland. Okay. Yeah, this one's for a desktop radio, a weather alert, a WR 120EZ donated by Storm. The winner of it is 378017. We have another of the portable weather radios. And these, by the way, if you haven't seen one, they can actually be programmed for local same codes for your local counties, but they can also be switched over to travel mode where they'll pick up the closest tower to wherever you're at traveling. Okay, the winning number for it is 378021.
Close, but no cigar.
There you go.
We have one final radio, another one of the WR120EC desktop radios.
I'm going clear to the other side. I'm gonna let you draw your number.
Okay.
Three 78009.
Hey, Marshall won one.
No. With me.
Hey, Mike, whenever you're ready.
This part will focus more on actually identifying the storms. So far, I haven't really talked about what you do when you're out there looking at a storm. I've talked about everything but that. Here's a diagram of a supercell, and ideally you'll be able to see all of this in one shot, but it'll never happen, because in order to see the top of the storm, you have to be far from it. In order to see the tornado, you have to be close to it. So I don't think you'll ever be able to see this, but in any case, the tornado and the wall cloud are usually on the back side of the storm. In this case, the storm is moving from west to east, so you're kind of looking toward the north at it. And the downdraft in the rain shaft area is kind of on the front side of the storm, and the tornado usually is on the back side. Of course, this is a supercell thunderstorm, which is the kind that we're going to talk about in this part of the class.
Storms with strongly rotating updrafts, also known as supercells, develop when the wind veers or turns in a clockwise direction through the lowest mile of the atmosphere. When the wind speed is sufficiently strong and veering with height is present, horizontally oriented rolls develop in the lower levels of the atmosphere. When these rolls are tilted by a thunderstorm updraft in a rotation about a vertical axis, a mesocyclone may develop. A mesocyclone is defined as an area of deep storm scale rotation, usually associated with a strong updraft.
So what he was just saying, that's just a fancy way of saying that wind shear is needed for supercells. That's all he's saying. When you have a lot of wind shear, you have a tilt to the updraft that gets the updraft rotating. All right, a thunderstorm, if you remember nothing else about thunderstorms, remember that they're vertical and they have updrafts and downdrafts. That's the two main things about a thunderstorm. The updraft is the warm, moist air that flows up into the storm, and the downdraft is when that air gets cooled off and comes down with the rain and the hail. And that's how a thunderstorm behaves. That's what it's about. So you can kind of think of a thunderstorm as an engine, basically. The updraft tower, that's that cumulus tower. It is basically the warm, moist air being sucked up into the storm. It's kind of its gasoline supply, so to speak. And the updraft can take on rotation, so that's where you have your tornadic activity like the wall cloud or your funnel cloud. And then the downdraft is the dark part of the storm where you have your rain and hail. That's where your rain-cooled air is. You might have a downburst, straight line wind, and sometimes you get a shower cloud preceding it. So we'll take a closer look into the characteristics of each type. Here's a time-lapse video of an updraft. And the only reason you can see the updraft is because there's some smoke from a grass fire that's being drawn up into the storm in the updraft. This is in Texas. And the downdraft area, obviously, is on the right side. That's where the heavy rain and the hail is. And it looks like you'll see some rotation in the updraft. Of course, this is the supercell thunderstorm. Now, the updraft region of the storm is normally accompanied by a rain-free cloud base. Obviously, the updraft is pulling up the rain and the hail, and that's why it's a rain-free base underneath that updraft. Usually the updraft is on the back side of the storm. It's underneath the big cumulus tower, which is the main part of the storm. Out of the rain-free base is where you would have your wall cloud, which could also form a funnel cloud or tornado. And normally you'd see some kind of upward cloud motion. You'd see cloud fragments or pieces of clouds kind of being drawn up into the rain-free base. And in case you supercell, that updraft can take on rotation. You can kind of judge the strength of an updraft by looking at a storm. If there's what we call an overshooting top, meaning if you see a cumulus cloud punch up over the anvil, it's kind of punching up through the ceiling of the atmosphere. That anvil is the ceiling of the atmosphere, and the updraft is so strong it punches above that. Another sign is if the cumulus cloud has really crisp edges like cauliflower, that's usually an indicator of a strong updraft. So low-level storm clues, if you're looking for wall clouds or tornadic activity or rotation, usually about 3 to 8 miles from the storm is the best, because if you're any closer than that, you're too close or you're losing the big picture. If you're too far away, you won't be able to identify the features. The rain-free base is a low, flat cloud base with little visible precipitation falling, and it has updraft towers above it. Every storm has a rain-free base, so don't freak out every time you see a rain-free cloud base. We're just talking about supercell thunderstorms here. And finding the rain-free base is kind of important for locating wall clouds and other important features. Now, I keep saying wall cloud, what is that? Basically, all it is an isolated lowering of the rain-free base, and I'll show you a lot of pictures here of what I'm talking about. Usually it's near the north side of the updraft, and it always has to be attached to the cloud base. It's not unattached. Usually a wall cloud is 1 to 4 miles across, and it may or may not rotate. By the way, there's a difference between rotation and shear. A lot of people, when they see clouds moving in different directions, they report it as rotation. Just because clouds are moving in different directions is not rotation. That's simply differences in wind direction with height. You can have winds changing direction without having rotation. So remember that if you have rotation, you're going to see basically a circular motion to the clouds. They're going to be moving in a curved type of motion. Here's a couple pictures of wall clouds. The one on the left is a very dramatic example, like a flying saucer type appearance. This is not real typical. More typical for our area would be the one on the right, which was photographed in New Madrid County, Missouri, which is in our 58 county area. And you can see it's exactly what I said. It's a lowering of the rain-free cloud base, and it's usually on the back side of the storm. The downdraft and the heavy rain areas would normally be on the east or northeast side if you were facing north. Always report rotating wall clouds because they are the precursor to any tornado activity. And you don't have to have a wall cloud to have a tornado. But, in fact, on the flip side, not every wall cloud produces a tornado. In fact, most wall clouds don't produce a tornado. But 90% of the time, if there is a wall cloud associated with the storm, there's rotation, broad scale rotation with the storm. And the radar is good for seeing the broad scale rotation. So we'll usually have a tornado warning out for that. But the radar is not as good at seeing the small scale rotation. That is the tornado. And that's why there's so many tornado warnings. Because we can see the broad scale rotation, which is common, but we can't really see the small scale rotation, which is the tornado. If we could, we wouldn't issue as many tornado warnings as we do. Some tornadoes can form without wall clouds. Wall clouds can form either from cloud down or from the ground up, but no matter which way they form, they will be attached to the thunderstorm cloud base. The vertical updraft, and basically here it just describes the different ways that wall clouds form. Many of them form when cloud elements build beneath the main thunderstorm cloud base in the updraft area. The vertical updraft then lifts the cloud element up until it attaches to the thunderstorm base. That's one way. Other times the wall cloud will form as a portion of the thunderstorm cloud base lowers toward the ground. And then the lower cloud can expand horizontally by adding cloud elements. Even if there's no wall cloud present, you will always see low-level rotation before a tornado forms. So rotation is the key here. Organized, sustained, focused cloud motion around vertical axis. That's what you're looking for, is that circular motion about a vertical axis. Now here's a time lapse of a developing tornado with no wall cloud. But notice you can still see that low-level rotation in the clouds. Here are some characteristics of a wall cloud. One of the biggies is persistence. It's not a come and go type of thing. It persists for about as long as you can see it. It will last at least 10 to 20 minutes, and most supercell circulations last for as long as the supercell lasts, which is an hour. Usually on the order of an hour. Sometimes, I don't know, some supercells have lasted for 12 hours. So they last, they're persistent, the dangerous ones rotate visibly and swiftly. Surface inflow simply means that the updraft blowing into the storm is fairly strong, 20 to 30 miles per hour, so that if you're facing the rain-free cloud base, you can feel that wind against your back because it's sucking in that warmer, moist air. And then a lot of times you'll see rapid vertical motion, meaning you'll see little cloud fragments being sucked up into the storm. Sometimes you can see them coming down as well. And if you've ever, I saw this in dramatic fashion one time when I was looking at a storm near Ina, near the Franklin-Jefferson County border. And there had been a tornado warning for it, and I remember distinctly seeing the up and down motion of the cloud fragments. I saw both up and down at the same time going on.
It's on the ground right there by the, oh my God. It's so quiet. It's so quiet, right here.
likely see. Here's time lapse, and when you speed it up, you can see the rotation a lot more easily, and you can also see the upward motion of the cloud fragments going up into the cloud as well. Funnel clouds and tornadoes are essentially the same thing, except that a tornado is in contact with the ground, and the funnel cloud is not. So both rotate, and both are come from funnel-shaped clouds, and both are attached to the cloud base. The only difference is that the funnel cloud does not reach the ground. And if you don't see rotation, it's neither a tornado or a funnel cloud. Keep in mind that there are times when the funnel cloud may not be visible all the way to the ground, and this happens on occasion where a tornado actually is invisible in the lower part. You can see the funnel, and you can see the debris at the ground, but you can't see the funnel cloud in its entirety. So if you see debris and you see a funnel cloud, you may have a tornado, even though you can't see the entire tornado. The downdraft region of the thunderstorm it's not where you're going to see the tornadic activity, but that's where you're going to have your very heavy rain. You may even have microbursts, meaning strong straight line winds. Those can be dangerous too. Those can be 70, 80 miles per hour plus. And you also have heavy rain, hail, possibly big hail. Supercells are known for producing the biggest hailstones of all the thunderstorm cloud types. And then the leading edge of the downdraft may have a shelf cloud, but normally a shelf cloud is associated with this squall line.